and a half. Would anyone like to volunteer for a virtual gold star to take notes for the second half for the second half of the meeting, the second hour? Clearly, everybody had very good lunches. Mikhail's going to be our Jabber scribe. We do need reviewers for working group drafts always. And in general, please add TSVWG to any ID submitted. My hardworking co-chair didn't do that to one of his drafts. He'll explain why later. Okay, standing reminder, document quality relies on reviews. Please review documents in your working group, at least one other document from another working group. If you'd like documents that you care about reviewed, please put in the effort to review other documents. Okay, accomplishments and status. We had grandiose plans to get a whole lot of stuff done since Montreal. We got a few things done, but as you'll see, best laid plans of mice and men went slightly off the rails. The DSCP IANA process changes draft is published as RFC 8436. This is setting up for getting the lower effort, the DiffServ lower effort PHB draft published, which should be happening between now and Prague. We have one internet draft in the RFC editor queue. It's been there a long time. DiffServ and WebRTC QoS. It's in misref state against several WebRTC drafts. And if you read Alyssa's blog, this is part of the infamous cluster 238 that the WebRTC folks are really trying to clear this time. Fortunately, all of our other drafts that were part 238, we've managed to extract. We won't tell you what tools we used and who we used them on. So this is the only one left, and I am fervently grateful that TSVWG is not on the critical path for the WebRTC draft tarball. Thank you very much to everybody who helped us get not get into that state. All right, 3 internet drafts at IESG. The SCTP errata and issues draft is there. There'll be an update later in this meeting. Spencer is losing yet more of what little hair he has over this one. The 2 FEC drafts are at the IESG. We will have an update on those later in the meeting. The framework extension draft is in fine shape, needs a few minor edits. The sliding window random linear code draft, which actually explains how to do something useful. In general, number discusses there are some security issues and some issues around source code and source code copyright. Vincent will be here later in the meeting to update those. DiffServ lower effort PHB is still in my hands. My intent is to get the RFC publication request to be submitted later this week. It finished working group last call. We've made some minor updates, and I simply ran out of time in October to send the publication request. So not to worry, Spencer, you still have a job. No IDs from last call. We're going to need to re-last call the ECN encapsulation drafts, the 2 shown here. We had people who signed up to review, and then your working group chairs neglected to nag the reviewers. We won't neglect to nag the reviewers next time around. We won't name names to protect the innocent. There are 8 additional working group IDs, internet drafts shown on the slide. Transport header confidentiality impacts has been added since the last IETF, but this is the usual cast of characters. We're moving forward on them. All right, related drafts. The font's gone down on this slide. We're clearly getting popular. There are 3 drafts on IPv6 path MTU discovery. Ole Tron, whose last name I hope I haven't butchered too badly, is going to talk about the one in the middle, which is a general sort of solution space draft, exploring what's possible. TSP, go ahead.
That one's on Wednesday, not Monday.
Okay, sorry. So you're talking about it in this meeting. I forget, last time around we had all the sessions on the same day. TCP encapsulation considerations, IPv6 reservation protocol, priority scheduling switcher, priority switching scheduler. Yeah. Draft Finzi. This one's in good shape. There have been reviews, and here I get to pull another out of my pocket to thank reviewers. Vincent Roca, Nicholas Kuhn, I think it's now a co-author of that, myself, and Rudiger Geib all reviewed this draft. I talked to the independent submission editor at the reception yesterday, and he agrees that what we're planning to do with this draft, which is send it to the independent submission editor with a recommendation from TSVWG, seems like a fine way to handle this draft. Overlay forwarding behavior, this is on the Wednesday TSVWG agenda, but we might get to it today depending on how we bash the agenda, and a draft on passive RTT measurement that is a generalization of the well-known, perhaps too well-known, quick spin bit. Over the SFC working group, draft Eastlake is still being worked on. This is going to be the use of the tunnel congestion feedback mechanism in that expired draft, and work in progress. 3 drafts in the interior working group. Draft interior tunnels is a general draft about tunnels. For us, it's the MTU considerations that are particularly relevant to this working group. Fragmentation fragility and SOX protocol version 6. Okay, so the agenda here. We will do agenda bashing in a minute. Monday's agenda, document accomplishments and status, which we're in the middle of. Milestones review about to come, and drafts. And on Wednesday, yet more drafts. Okay, milestones review. This is where some of our best laid plans ran aground. These are all yellow/orange because we didn't quite get them done. First one will happen this week. I will get the publication request in on the lower effort per hop behavior. The next 3 September milestones are for the L4S drafts. We were a little bit overly optimistic about when these are going to get done. Your chair's best guess right now is we're going to put June 2019 dates on them and hope that's more realistic for getting these 3 core drafts through. We still have open technical issues against these. October, there were 2 drafts. These are the 2 tunnel drafts that need to be working with last called again. We're going to move those dates to February 2019, hoping that we can last call them. Nothing major happens, and they can be submitted for publication thereafter. The SCTP NAT draft. Well, that was an interesting theory. It got delayed by the SCTP errata adventure, about which we'll have more to say this meeting. We're going to move that to April. UDP transport options. This one seems to be relatively stable. It's on the Wednesday agenda. We're guessing that it's just about done, and we may be able to submit it for last call in like January or early February, submit it in February. Packetization, pathway MTU discovery for datagram. That means UDP and the like. December 2018, we're optimistic, move that to August of next year. And tunnel congestion feedback, I have no idea. This one's taken a while, guessing April 2020. December 2019 is still a good guess for the SCTP BIS draft, and we need to add a new milestone for transport header confidentiality draft, and we're going to put that as September 2019. Any comments from anybody affected or not affected by the milestones? Seeing none, we'll carry on with that. Okay, so here we go with the agenda, and as part of the agenda, we're going to cover a few small items as part of the agenda review. So we've just done working group drafts, lay drafts, and milestones. An errata reminder, just shortly prior to the Montreal meeting, we put an errata into RFC 8311 Eastern experimentation. IANA needed a justification to put a footnote in the registry that ECT1 is for experimental use only. We filed the errata. IANA put the footnote in the registry. Nothing to see here. Move along. Agenda bashing we're about to get into. Gory, anything on hackathon update?
Does anybody have any work on the hackathon that they want to report? I know that Tom's done stuff on implementation work that he's going to talk about on Wednesday. Is there anybody else do anything that they want to talk about? Please tell us, and please do work in the hackathon. Carry on.
Okay, check that off. All right, into today's agenda. We're going to start with the transport header encryption impacts. Then we get an update from Vincent on the FEC drafts, and I suspect we're going to have some AD discussion there to make sure we understand what the options are for the path forward there on the FEC scheme draft. Then we do L4S, which is going to include the out-of-order forwarding discussion. There's also an L4S and DiffServ draft that comes up as a separate agenda item to try to isolate those. There'll be an update on the Quick and ECN discussion from last time. And oh, by the way, if you're interested in transport issues in Quick, tomorrow's TCPM session, 11:20 to 12:20, is entirely devoted to congestion control and loss recovery comparison between Quick and TCP to take a look at how Quick is doing things and dig into the details. If you're interested in that, now you know what session you're looking for and when it is. New work on DiffServ as time permits. DiffServ to QCI mapping. Is there anybody here or on the remote to present on this? I don't think so. So what we're going to do is we're going to swap this with the last draft on the Wednesday agenda, which is the overlay forwarding behavior draft. As I believe one of the authors of QCI draft will be here on Wednesday. Non-queue building flows, and then Bob gets up for round 2 for more L4S and DiffServ discussion. Moving to Wednesday. Wednesday is the transfer protocol drafts, UDP options, and there's Corey's draft without TSVWG in its name.
Thank you, David. It's not got TSVWG in the name because it's a feedback from a map RG presentation, which you might want to come to in between the 2 TSV sessions.
That you might want to come to is aimed at the entire working group. Just having fun up here. SCTP drafts, probably mostly about 4960 errata. What are we going to do about that? And moving forward in 4960 BIS. Datagram, PLMTU discovery. And then more PMTU discovery, this time in IPv6. And finally, we're going to swap this overlay forwarding behavior draft with the QCI draft. In my copious spare time, I'll prepare an updated version of these slides that reflects that swap. Okay. Anything missing? Anybody want to further bash the agenda? Well, you can tell all your friends and family you actually saw an agenda bash. We made some changes. One more related event this Saturday. Saturday afternoon, there's an IEEE 802 IETF data center workshop. Paul Congdon, whom you've seen here working on congestion isolation, is the principal organizer of this. There are several congestion topics on the agenda. If you're here Saturday afternoon, this might be a productive use of your time. It's in this hotel. There's no fee, but you do need to register in advance. Details and I assume an ability to find the registration link are at that URL. And Paul, you want to stand up for a minute or raise your hand? If you have any questions about that, that's Paul. All right. Let's see what. Hang on a minute. All righty. Let's see, what are we up to next? All righty. Tom's going to do that one. Okay.
Colin, are you going to talk about the draft that we've been working on? That would be okay, but I'd like you to take the wonderful red box.
Pink box. Pink box.
I prefer to call it a red box.
We're too manly for it to be a pink box.
Okay, if you want to stand in a pink box, have a control and do so.
All right. Hi, greetings. My name is Colin Perkins. I'm going to be talking about the draft we have on the impact of transport header encryption on network operations. Okay, that didn't do what I expected it to do.
I have no idea what happened.
No idea what's happened there. Here, you control this. I will say next slide. So next slide, please. If we can figure out how to work the slides.
Hang on.
Yeah.
This is what happens when you format the slides of 4:3 aspect ratio and the screen is 16:9.
Shouldn't be the problem. Well, okay, this was one solution. Yeah, okay.
All right, now that plus that.
Yeah, and then we go forward one.
Try the clicker.
Yeah.
Clicker.
There we go.
Okay, excellent. Good. We'll see if we can work it
It
now.
takes 2 working group chairs to outsmart a Chromebook.
Two working group chairs to work a PowerPoint. All right. So we.
Okay, maybe 3.
If you can do it at first attempt, they make you an area director, right? We have been running this draft for a while. I presented the 09 version of the individual draft in Montreal. We got some feedback at that meeting. We submitted a -10 version in August to hopefully address that feedback. It was then adopted as a working group draft. The 00 version of the working group draft was submitted with no content changes, just a change in the file name. And then we submitted the 01 version just prior to this meeting to fix a few more nicks. Changes since Montreal, we have added a set of examples, briefly talking about showing the impacts of ossification on the transport protocols. In particular, this mentions multipath TCP and the issues with middle boxes that track congestion window growth and get upset when multipath TCP, at least some versions of it, made the congestion window grow in a way they didn't expect. We mention briefly TCP fast open and the issues with middle boxes, which misbehaved when they saw unknown TCP options, or that get upset when you send data on packets with a SYN bit set, and things like that. We talked about some of the issues with SAC, where there were middle boxes which rewrite TCP sequence numbers but don't understand the SAC option, and therefore end up with very inconsistent TCP packets and cause chaos, and so on and so on. We've also revised the introduction to perhaps better explain what the point of this draft is. We've revised some discussion about the observation points and the rationale for on-path measurements, which just wasn't terribly clear. To keep Brian happy, and then he goes and not turns up to this meeting. We've referenced the wire image draft that he wrote, and we've made a bunch of editorial fixes and updated the references and all those usual things. So, open issues remaining. Not too much, I don't think. We need to look at and revise the conclusions, which are currently long and perhaps could be described as rambling and not necessarily making a clear point, and just make them a bit crisper and actually have a clear conclusion in the draft. And we have a section in there which is talking about metrics derived from the network layer headers, which are, again, it's not quite clear how well it fits in the draft. Some of the discussion there about things like ECN code points is a clear relation to exposed or not exposed transport headers, and that I think is a clear fit with what we've got in this draft. Other parts of it talk about things like diffserv or the IPv6 flow label, and there's clearly good operational reasons for looking at those for managing the network. They have obvious implications for end-to-end performance, but it's not clear they necessarily interact with the issues around encrypting the transport headers. So we might consider taking that out. Also, if we wish to talk about some of the work people are discussing with the path layer, and I'm hesitant to say the word plus or spud, but plus or spud, then this would be the appropriate section to do that if we want to do it. And we're considering whether to expand that section and include that sort of discussion, or just to trim it down to something much more focused on perhaps just ECN code points and not a whole lot else. And if people have opinions or suggestions for what the right way to go in that is, then we would be happy to hear them. And similarly, if you have any suggestions for what you think we ought to be concluding, then we would be happy to discuss that and hear what you think. And if not, we will just conclude something. But we think the draft is pretty close to complete. As I say, we're looking for input, but if not, we hope to revise this and get it ready for working group last call, certainly before the next meeting. Okay.
Have you had any review from the privacy community yet?
We have had review from a bunch of people, some of them who may count as being privacy. Do you have anyone in particular in mind?
Yes, but name not mentioned at mic to protect the innocent and the guilty.
Okay.
I could use my working group chair hat to ask, should we make any recommendations in this document, or should we just conclude? I mean, on that maybe isn't really to Colin so much as to the rest of the working group.
Yeah,
This document exists at the moment with conclusions summarizing what it says. It doesn't make any recommendations about the future. That could be the place of another document. May well be. But if people have a strong opinion on this, please speak up before we get to working group last call.
Yes, I mean, my opinion is that this would probably be, this is probably better suited as a draft which discusses the issues. And if someone wishes to make strong recommendations for what people should do in future, that's a different draft. We may make a conclusion that it would be perhaps beneficial for someone to write that draft. And I see a couple of people nodding. And not volunteering to write the draft, I suspect.
And the AD headed for the mic.
Spencer Dawkins, the outgoing transport area director. It feels so good every time I say it. The thing about the discussion of the issues and then what the plan is after that. I think that's going to be really important to do that in two pieces, and I'm saying that not just because I think it will be easier to get the first material out if there's not a lot of baggage with it, but mostly to say that I expect that output to be useful in a variety of places at the IETF and outside the IETF, and places that could have reasonably benefited from it 5 years ago. So to me, hanging on to that a minute longer than you need to hang on to it is not serving the internet or the IETF well. Don't let go of it before it's ready. I'm not asking for that, but I think that what you were suggesting, my understanding of what you were suggesting, is exactly the right thing to do from my perspective. I've been wrong before,
Surely
and I'm
not.
willing to be
Surely not.
I'm willing to be convinced otherwise. But that's my best guidance to you all.
Okay, thank you.
Michael Abrahamson. So the same way that you in the beginning here had drafts that are relevant to this working group, I think this work is relevant to other working groups. So we should ping before last call here, because I'm going to read this document, and already I saw the MSS statement here interfere with path empty discovery. I don't understand where that statement comes from and why it states that. Would like to know more. I'm going to make that comment, on the list. I'm sure others will want to make comments on other stuff in the draft. So we should ping relevant groups who are, in the business of moving packets and see if they agree with what's in the document.
Okay. Okay. Where am I talking as an author? Let's be clear on this. As a co-author on this, I think that's really valuable. And the reason I asked the other question was to figure out, because we may nearly be done with this, and it may be just the right time to start asking wider input on this document. If it's looking good, next rev should be put before other people to really see that they have a buy-in. I see Colin nodding, and I guess he'll say more if he wants to.
Yes. So the MSS thing may just be my sloppy writing on the slides. So read the draft before commenting on based on the slides.
No, I read it. It has the same sentence in the draft. It says TCP MSS rewrite might interfere with path empty discovery. It's in the latest rev. So you got it right there. It's what's in the draft, and I don't agree with it. So I want to know more.
Okay,
And
please,
I
please
think
do.
there are going to be more of those things. So yeah, I think you're right that it should go for wider review.
Yes, I mean it has been discussed in at least OPSEC, I think it was at the last meeting. So it has had a little bit of wider review, but yeah, more is clearly welcome.
Okay. Can I take you up on the MSS thing? while
Okay.
you're still at the mic.
Yeah, sure.
So if you do MSS clamping, then this is as an author rather than as a chair. But if you do MSS clamping, then you inhibit what your PLP MTUD algorithm can then increase the MTU to. So if there's a path MTU of 16K and the MSS clamp to 1500, then 1500 is the biggest you can go to according to the TCP spec.
Correct.
Which means that now you can't figure out the path actually supports a bigger MSS, which it does, because the end system says it does, because the MSS is an end-to-end negotiation. And therefore, this seems to be some sort of combination of two different things. The end-to-end negotiation of what the maximum segment size was done at the end-to-end point, and then the network somehow changed that to prevent it doing path MTU discovery.
Sure.
Okay.
I'm just going to say, do you want an answer now or? Okay.
Yeah,
Okay.
let's have a little bit of discussion. And then we
Okay.
can-
So the operator who put in the clamping statement there on the router probably had a pretty good idea what the MTU was on the link that is handling these packets. So this is like the way I see people using it is okay, PPPoE, and by the way, we screwed up the path MTU discovery, so we're going to clamp MSS to 1452 or whatever it is for V4 to do this. So even if the end systems have 16K MTU, it doesn't matter. All the packets need to traverse this link where the operator said, I want to clamp the protocol.
Sure, I can give you lots of data which shows that operators at some point in the network path are clamping to numbers that are smaller than the actual segment size they actually support. We did probing measurements.
Sure.
And these were not people who were doing nice PPOA or whatever encapsulations. They were people who were optimistically reducing a little bit to make the network a little bit more reliable in their view.
Sure.
So maybe we should clarify about this.
Yes, but it's like, okay,
Sure.
so there should be more, if there is a discussion somewhere talking about this, we should reference it, and otherwise the statements as is not enough text. There needs to be something more about it.
And that was a good thing to have at the mic, because we accept any comments similarly on any other pieces.
Yes, but if you could send something to the list, that would be helpful. Yeah, thank you.
So Spencer Dawkins speaking as the research group draft editor for the PAN-RG What Not to Do draft, which is, I think, in some ways similar to this, because basically you're characterizing a whole lot of stuff that didn't happen here. I've found with my draft that it's turning out to be important to get people who are responsible for the things that I'm characterizing to look at them and make corrections and things like that. To me, that's almost like an early review thing that you could kick off at any time. So I trust you guys to manage the working group. Speaking back as Spencer, the area director, but
The outgoing area director.
speaking back as the editor, my friendly advice would be, don't wait till IETF last call to do that, because you don't have to have that conversation in front of everybody. You just need to have it in front of somebody who knows you're wrong.
Thank you.
Martin Duke, F5 Networks. I don't know a diplomatic way to ask this. What do you hope to achieve with this draft? Obviously, Quick is pretty far down the road of hiding all this stuff. Are you advocating that future work in the Quick working group expose this stuff in network headers?
No, I'm advocating that there be a discussion between the protocol designers and the network operators to figure out what, if anything, needs to be exposed, and if things are not being exposed, if we find, to figure out a way of addressing the needs which those network operators have been addressing by looking at the transport headers.
Okay. So I'm sympathetic to that viewpoint in many ways, but the spin bit experience suggests
That's
that
a lovely experience.
That's going to be very difficult.
Sure.
for anything non-trivial.
Sure. I agree.
Thanks.
Elisa Cooper said on Jabber that she thought that this should go to for security area review as well. And so not only like trying to reach operator packet movement, but also security people.
Yes. Yes.
Should we do that soon, David? After the next rev or two?
That sounded like what I think I heard from Colin, which is that next rev we're ready for wider review. I'm going to guess off the top of my head at least ops int and security.
Yes. Yes.
And-
At least one, I think former at the time security AD has given us extensive feedback on this. So it has had at least some input from that community, but more is clearly better.
Yeah. So Spencer Dawkins speaking with a couple of hats. I ended up being the editor for the Marnu workshop report, where the IAB had a joint workshop with GSMA talking about how to manage radio networks in an encrypted world, which is something like what Marnu actually stands for. That conversation was not well informed. And I get to say that as a transport area director who was sitting there. This document would have helped. I balloted on the MMM-Crypt draft that went through the IETF, and it seemed like to me that this draft would have been helpful for that situation also. So I can point to at least two worked examples where I think, as the responsible area director for this working group and a few other things, this would be helpful. Speaking as one of the two responsible area directors for the area, we had this fascinating conversation in TSV area today that was basically talking about kind of veering off into discussions about, we knew what we were doing with PEPs in 1998 when we published RC, what was it? 3145 or whatever it was in 2001. That actually came out in 2001, but the work was done before that. But we in transport have not really had a meaningful conversation about what PEPs were intended to do and why they were done. And again, I think that this work informs a discussion like that. I can only say as a co-chair of the concluded PILC working group, the satellite links are still out there. Step one, right? So what people do about that, that's up to satellite operators. But again, I think this is work that will inform a lot of conversations that will be had whether they are informed or not. Notice that I didn't mention Quick in the spin bit, which I'm also responsible for. Ask me about my week.
Okay.
Okay.
Thank you, everyone.
Thanks, Colin. We'll revise the draft.
All right, thank you. Let's see, next up I think is Vincent. Let's see. Remember the trick is to do that. Hang on. We have slides, but what I do need to do is I do need to hit reload here.
Wait a bit.
All right.
So to give context, the document that Vincent's going to talk about was discussed in two parts. The one part's already gone through IESG. This part raised discussion items from the IESG relating to how the document is put together, and here we have the slides. Go talk about the results of the IESG review.
Yes, so this talk is more specifically focusing on this second document, RLC sliding window scheme. We got very, very good comments from ISG during their review on this document particularly, so I will try to discuss and address some of them. The document has not yet been updated, and we are still working on the answer to the ISG review. Okay. So most of those comments, the most important comments were about the TNMT32 PRNG, the pseudo-random number generator. And just some background on this, we have two parts. There is the core part of this PRNG, which produces a random number as a 32-bit value. So this part is coming from the PRNG authors. I'm not concerned about this. And we have the second part, which is mapping of this value, 32-bit value, into something smaller, typically 4 bits or 8 bits. So that's the mapping part. And we have our own code to do this mapping. So this mapping is quite important because if you do that the wrong way, you will introduce biases in the output. So we need to be very careful about it. And we also want something that is not too computing intensive. So let's go to the comments and see how we propose to address them. So the first comment was about the core part itself. Is it safe across several types of platforms, several types of CPUs, operating systems, of compilers? That's a very important question because the deterministic behavior of the PRNG is a key point for interoperable FEC codecs. So that's very, very important. So our proposal is to do better tests, in particularly focusing on very small devices that run specific microcontrollers, Cortex M something, M0, M3. We have that in mind. And I'm proposed to do that work with Emmanuel Bacheli, my colleague, who's particularly competent in this domain, who's one of the Riot first authors, so these Riot operating systems. So we started to do tests on those very small devices and compare them with what we observe with laptops with more powerful machines. And the core PRNG seems quite okay. So we still need to do additional tests, but it seems okay. And the mapping to a smaller range of value needs to be tested. So we're working on this. Of course, there is no way we can guarantee that it will continue to work on future CPUs, on future compilers. But well, is this really yes, it's a major problem, but it's quite small piece of work. And additionally, I forgot to mention this in the slides. We want to include set of values that must be produced by the PRNG, including mapping, to be conformant. So there will be in the document a set of values. If you don't produce this set of values on your target platform, this will not work. This cannot work. So I think that with that, it should be okay. Second comment is about licensing aspects. So we are copied and pasted some C code inside the documents. So it comes with the original license of the authors. And there is no way we can remove this license. It's not, well, possible without the author authorization. So there is potentially a problem here that needs to be discussed. There is no way to abstract the PRNG, providing just the algorithm of this PRNG, because it's something quite complex. And I will make mistakes if I'm trying to translate it into something more in an algorithmic way, in an algorithmic manner. So I prefer to keep it as such. So we need to find a way to address this solution. Is it compatible with the IETF, let's say, license? Yes or not? I have no idea on this. The original license is more or less a BSD license, so it's more or less.
It's not more or less. The original license is, in fact, BSD version 2.0 3-clause license. Full stop.
Okay, thank you. So that's an open point. I have no answer as far as I'm concerned.
Mia Kulevin as the AD holding the discuss for this processing issue. So the problem is not the license. The BSD license is conforming with the IETF license on purpose. The problem is a copyright statement in there, because there's a copyright statement that the copyright only belongs to the original authors, while the copyright statement of the whole document, including the code you've put in there, says the copyright belongs to the IETF and only the authors of the draft. So this is a conflict that we cannot have.
Okay, I misunderstood the comment. Okay.
Mira, do you understand how it might be fixed? Perhaps there's an option.
So, I mean, two options we have, and I'm not sure if these are great options, is removing the code and just pointing to an external stable reference, or removing the code and translating it into pseudocode. And that is actually a point I wanted to make on your concern one. I think the main concern here was not the actual technical details, if it will run or not or whatever. The main concern brought up was also that it's not a good practice to describe a specification in code, because that, like, it's hard to update. It's like, yeah, it's just better practice to describe the specification in English language and provide pseudocode as examples.
Would it be possible to include it as an annex?
So the one that has a copyright statement is in the annex.
Yeah.
I actually put another question on the legal counsel we have and say, can this not be regarded as a literal citation of something, right? And I didn't get a reply, but I think the answer would be no. If we can find a different solution, that would be better.
I would observe that the problems here are being caused by the fact that this is third-party code.
Yeah.
And it is also the case that the copyright statement that causes the problem is in fact part and parcel of how the BSD license is used. So it's not like somebody did something weird.
No, but like what we usually see is that we have code in a draft where the code authors are the same authors than the draft authors, and that's not the case.
And hence can grant copyright.
But maybe one way to go forward is to ask the original authors, the two Japanese authors, if they would agree to change their license or to join as co-author. That's one possible way to move forward in that case.
In theory, that is a possible case, yeah.
Colin Perkins. So I have no input on the copyright issue, but just to follow up slightly on Miria's comments, we do have a long history of including code in RFCs to illustrate things. So I don't see that having the code is a problem if we can resolve the licensing issues.
Okay, yeah.
So, and the comment was, and I'm just reflecting other comments from other ADs, was it's a problem to have code as the only specification. You still should specify the protocol in other terms and only have the code as illustrating what you mean. Like only having the code as a specification has caused problems in the past.
I understand. And
Spencer Dawkins is the responsible area director channeling Miria, who is channeling other ADs. The best people to talk to that I've tripped over in ISG evaluation with this are probably Ben and Adam, and maybe perhaps Ecker. I'm trying to remember, but at least the two of them that were involved in the codec work to produce the Opus codecs and codec, and basically the specification. The code was the specification, but everybody changed the code in their implementations. So when they wanted to update the specification to add some functionality, they couldn't talk about functionality without everybody going and figuring out what they'd done to their code that would be different and seeing if they could still do it. And so it made it very difficult to evolve what they were talking about doing. You guys could come up. I mean, let me try and help. You guys could come back and say, this is the future. It will never change. That would be a fine response. It might even be true. You can come back. You can come back and say, the pseudocode thing, lets people who have made changes to the code that's the specification, that was the specification, and was included in the draft, included in the RFC. It helps them to to have the conversation about new functionality without having to read code, without having to read each other's code, basically at that point. So I mean, I think there's ways out of this, and I would really like to work with you guys on figuring out what those are. If having the conversation with the Japanese guys helps some of this, please feel free. If talking to me about sending me off to play with the IETF trust, and see what we could do. I'm happy to do that, as responsible area director. But like I said, just, you guys are doing, I think, a good job of working through the concerns that have been raised, and just trying to make sure that you kind of understand what my understanding is of all those concerns. So
Okay, thank you.
do the right
Okay.
thing.
Spencer, I wanted to inject here a difference from the Opus situation that may affect how we think about code as a spec. Opus was a codec. You do that, period.
Mhm.
Here I get to give Vincent credit for writing 2 drafts. He wrote this one draft in the FVC scheme that is including all that is consuming all of our time, and he wrote a second draft that allows multiple schemes to be registered. So those who choose to change the code should go register another scheme, and they can go write the code any way they would like to. We don't have to worry about migrating forward, which was not the case for Opus, which was the one and only true codec.
Very good point.
Yeah, an excellent point. And I think this points out again why it's important for the community to understand that discusses are a potentially multi-round trip discussion where both guys can say, yeah, but that reminds me about this other thing that's relevant to the concern. So I think that could be a fine thing to point out if it's helpful and true. Do the right thing.
So Gary, coming back with another one on those same thing. If the code is constructed in such a way using this that you need this to decode this,
Yeah.
which means that this actually is the only way of formulating this, because if you don't have this PRNG sequence in it, then you end up with a different code.
Exactly.
Yeah, so this is not like a codec where you have a black box and you're describing it using C and it's one way of implementing it. This is the way in which these pieces are put together as transport packets.
Yeah.
This maybe just needs to be clarified along with Spencer's point, along with David's point, and clear the copyright thing somehow. So you have several pieces, but they don't seem to any of them be difficult. They're just individual pieces that have to be put in place to get this through.
Mm-hmm. Okay.
If you're interested in that in the working group, please talk to Vincent. He's going to do the hard work, I'm sure, to make this work.
Yeah, thank you. Okay, and we had additional concerns, and this is concern 3 about the way we are using the PRNG. Is it the right way? So we were using floating point calculation, which is clearly not the best way to have always deterministic behavior. So we remove this and we move to full integer mathematics. So the next steps, of course, I will address all the commands related to RLC. Apart from that, and fake frame, much easier. We still have some work to be done on 1 and 2. Sorry, made a mistake on 1 and 3, and clarification on licensing aspects. Then I have also a question to you. Does it make sense to remove the PRNG specification from the current RLC document, have it something in a separate document, create a normative reference between the 2 documents, so as to divide the problems, I would say. So it makes it easier to and faster to clear all the ISG discuss on RLC itself. And it will also increase the visibility on this PRNG specification, which might be reused in different contexts for different protocols. We are missing something, I think. I did a quick search before going to this development. Is there anything, any RFC describing an existing and good enough PRNG? I found nothing, but I'm not aware of whatever has been published. So maybe I missed something, but I think there's nothing. So it could be meaningful also to have this separate TNRMT32 document. That's a possibility. We, at this level, we can do that this way, or continue the way it's done so far with a single document. An open question to you, if you have an opinion.
As trying to channel Wes, who isn't here, I suggest if you have opinions on this from the working group, please talk to Vincent or use the mailing list. Otherwise, Vincent, you should work with Wes as your document shepherd to find a solution. Please involve the 2 ADs who obviously have some expertise. Wes also will be able to guide you as to which of these options is the most likely door to push on first.
Yeah, okay. I will do that.
And we hope to see this published or going for publication by the next IETF, I hope.
Yes.
Well, thank you.
Thank you.
Spencer, while we're changing over to the next presentation, would you like to tell the work group what you just did while Vincent was speaking?
There is one more approved SCTP specification. Dum da dum dum.
Bob? And where's? Okay, cool. Let's see whether this works. Let's run the unit test first. No.
Because you have to. Yeah.
It appears to be working.
Okay. Right. Don't often have to lift the mic higher for myself. Right. This is a bunch of drafts that were decided to put into TSVWG so that it could sort of act as a container for the whole low latency, low loss, scalable throughput activity called L4S. Sorry, I've just realized it says IETF102 on there. Next slide.
You've got the. Oh, we're supposed to run the clicker for Bob. Okay.
Sorry, right.
Didn't see it properly.
All right, quick recap on L4S. The motivation is extremely low queuing delay for all internet traffic and all means including link saturating traffic. So ultimately, the idea is that everything can go in that L4S queue. The only reason there's another queue there is for legacy existing congestion controls. Typical measurements, you get about mean of 500 microsecond queuing delay versus about 5 to 15 milliseconds with your best state-of-the-art AQMs today. So, and the three drafts are roughly mapped to that 1, 2, 3 picture there. Although the order I'm going to do them in isn't 1, 2, 3. It's 2, sort of ish. Anyway, the idea is there's scalable congestion controls at the sender. There's a protocol which we've homed in on ECT1 as the code point that signifies this traffic. That's in the ECN field, and then there's the dual queue coupled AQM that does the work in the network. So the protocol is the first bit I'm going to go on to. But before I do, I'll just give you an overview of the whole talk. I think there's 25 minutes for this, isn't there?
20 minutes and 5 minutes of discussion of the reordering.
Yeah, of course. Yeah. Well, I've got discussion of the reordering in the middle, so yeah.
So you can get through that.
Yeah. All right. So there are 3 core L4S working group drafts in this working group. The architecture, the semantics of the identifier, and the dual queue coupled AQM. The architecture's been stable now. I went through it because I'm preparing for working group last call. I went through it with a fine-tooth comb, or a fine-tooth saw even. And to be honest, there was very little wrong with it, even though it was written quite a time ago. And so there's minor updates there. The identifying modified ECN semantics one was a lot more problematic in terms of it was written right at the start of the activity. It was the primary thing to do to get the code point standardized. And it was, to be honest, a bit of a mess. So what I did it in 2 updates. The first update, I restructured it so that the diffs weren't poisoned by that. I then did the text updates after I'd restructured it so you could see where they were. Thank you. Yeah. Don't think it will help, but I'll try. I can't get the top.
It's a two-step protocol.
Yeah. Right. I shall carry on. I'm male. I can't do two things at once. Right. So after that complete restructuring, I'm now reading down the green top arrow and making it consistent with the two other drafts and bringing it all up to date. There was a comprehensive rework of the section on other IDs, and that means other than this ECT1 thing, all the other identifiers that might possibly get used either within that dual queue structure or around it in queuing hierarchies and things. So I'll give a summary of that, but most of that is in the DiffServ talk later on. And then actually not in this cycle, we added this requirement to be rack-like. And hence it's in green because it's not gray because it's not in this cycle. But David has raised a question on that, which I will discuss or bring up, and it's essentially about incremental deployment of all these requirements. Then, moving on to the dual queue coupled AQM, this is a sort of top-level summary, so you know whether you can go and check your email or whether you really ought to listen at certain points. There are a number of extra normative requirements we've put in. During a review, it was pointed out that we hadn't sufficiently specified the thing. The maths wasn't rigorous. I'll quickly go through that. There's some, this doesn't sound very interesting, does it? Management requirement details. You know, there's only no words in that sentence that sound interesting, but there's some interesting stuff in there on how you measure queuing delay and how you compare it for the experiment and stuff like that. Then there's some, the other two bits are pseudocode updates in the appendices, and there's just a bit of news there on what we're doing, and you know, things like shared buffers versus dedicated buffers and stuff. Okay, and then at the end of the talk, I'll just give some heads up on what else is happening about L4S in other working groups and outside the IETF. So the first draft, identifying modified ECN semantics, the identifier draft. It's gone through 2 revisions. Bit of an eye test, this one. It shows the contents before and after, between 3 and 4. We're now on draft 5. And the primary point of all this is those 2 emboldened headings: prerequisite transport layer behavior and prerequisite network node behavior. Basically, all the sections are the same as the previous, but they're just all in different orders to collect together everything a network person has to read and everything a layer 4 person has to read. Right? And you know, 4 there were no text changes, but then all the text changes come in between 4 and 5, so you can see the diffs. Right. So there are, when you start talking about what other identifiers you might use around L4S, the first one is what identifiers you might use within it. And in the next slide, I'll talk about around it. And this essentially shows that the default situation is you just use the ECN code point and it will work, right? And it should work end to end, and measurements seem to show it is. And you actually only need the last bit of the ECN field to determine which queue it goes in. But in addition to that, if an operator wants to, they can put some more traffic, this is example 1, inclusion, into the L4S queue. Now you have to then call it an L queue, not an L4S queue, because you're putting non-L4S traffic into it. So it's a low latency queue. So you've got mixed in with L4S traffic, maybe stuff like VoIP, DNS, game sync updates, things like that, that are low latency, but also not queue building, not capacity seeking stuff, right? And so the idea is that you can freely use any form of classifier to do that. Maybe a layer, look at the DNS if you want. Look at your layer 7 protocol, or look at DSCPs for EF, for voice admit, things like that, to add to that. And there's a later talk from Greg White on possible new DiffServ code point called non-queue building that pulls together all those things like game updates and things I just mentioned. So you don't have to look around everywhere. Then the second example here, instead of inclusion, it's exclusion. It's saying, well, what if the operator wants to exclude stuff from that queue, either, or for some policy reason? I've given 2 examples here. A security policy reason. For instance, you've got a malicious host, you don't, sending stuff in there, you want to kick it out, or maybe a malicious protocol, that a badly formed protocol that you want to kick out. And commercial reasons, maybe an early deployment. Certain operators might want to say, well, let's do this for all our traffic, but other operators might want to say, we're just going to do this for our business customers or our high-tier customers or something like that. So we'll exclude anyone that isn't in that category from that L4S queue, even though it's got the right ECN code point. And so the idea there is that if they do that, it's a local thing only. So the ECN code point goes through their network unchanged, but they add another classifier that says, okay, you've got the ECN code point, but you're from a network that I don't want, you're from someone else's network. I don't want to give you this service. And so it kicks you off into the classic queue. And then later, if they want to make this an undifferentiated service, they can just remove that classifier and it will all start working, and the ECN stuff will still be going through, and it will be going through to everyone else's networks. So there's a very important must in the draft to say you must not change the ECN code point in order to do that. It survives your network, but you add another classifier to knock it out of that queue. Okay. So then the next category of classifiers and identifiers for those classifiers is when you're sitting within a DiffServ queuing hierarchy. And this is really, there's an arrow, green arrow on here saying this is mostly about what's going to be in a later talk. So I'm just going to give a flavor of it here. So the previous example was about splitting the default DiffServ class, if you like, into 2, assuming you only have the default per hop behavior in your network before you split it. But if you want to do some bandwidth prioritization, in the example here, maybe not just a voice service, but a priority voice service where it survives even if everything else doesn't, or something like that. So you want to make it survive in bandwidth terms if there's overload or earthquakes or whatever. You might want to have your DiffServ priorities there, and the dual queue as well. And then the L4S DiffServ draft talks about all the ways you might structure those queues and how you would classify where your dual queue is part of a larger hierarchy like that. David.
David Black, from speaking on the floor as an individual. Bob, nice slide. And in particular, I believe this finally resolves the confusing discussion you and I have had about classification. The diagram is excellent and allows you to make the point that I'm interested in, which is that for incremental deployment, I think it's important for an operator to be able to sort of go through their DSCPs in use and turn L4S on or off on a DSCP by DSCP basis. And that's roughly what's going on, because I've got 2 queues here, priority voice and priority VR, that have clearly been classified probably on DSCP before we even got here. And the stuff that didn't land in those 2 queues then goes through L4S. I think there's more text we worked on here, but I believe we have the structure of the solution here, and we just have to make sure that this upstream classifier, PHBs before dual Q, is something that is at least strongly recommended, if not required, because I think it's essential for incremental deployment, because it allows an operator to sort of go through her traffic and say, okay, we'll try this. Aha, it worked well. I'll turn L4S on bit by bit over time as I obtain more confidence in it.
Yeah. So, but I also want to emphasize that all this, theoretical discussion about how L4S might work with diffserv is theoretical discussion. We're just making sure it will work. We're not necessarily saying you've got to do this or it's sensible to do it. And the point of L4S was really, let's just make this separation between low latency and old stuff that causes high latency, and that should be enough for the public internet. So this is all added complexity that we didn't design to add it. I don't think you need it, but you could, right? And certainly in corporate networks that do all this bandwidth stuff, then they may well want to continue doing that. And the other point to make is that incremental deployment, which is David's point's a good one, incremental deployment isn't the only way this might happen, because once you've got a way to do latency without bandwidth, you might want to rearrange your classes rather than just subdivide them. Because a lot of those, like if you've got a voice class in your network, well, actually, you could probably put it into the LQ. This example gives an example with priority voice, but normally you could just, like the previous example, just put all your voice in the LQ and you get low latency. Michael?
I just needed to press return on, since I'm JavaScript. Michael Abrahamson. So you, sorry, I will have the same problem, it seems. So whatever you had before as a CQ, you keep that. So if you were running FQ coddle before, you now do that on the CQ and then you put that on top, or?
Are you talking about this slide here, or the?
Well, I was talking to that
this one
here.
Yeah. Okay.
Okay, we're talking incremental deployment. If I came from something, do I keep that as my CQ?
Right. Theoretically, yes. You could do FQ coddle in the CQ and couple it to the LQ. For instance, we show two examples in the draft, the dual Q draft. This is where you had pi in the CQ and then you can couple it to the LQ, red in the CQ and couple it to the LQ. FQ coddle is a bit more difficult because the coupling means you've got to couple some congestion level to the LQ, but you've got many congestion levels in all the different queues, so you have to have some mechanism for working out what the average of them is.
Okay,
right.
So I believe the buffer bloat guys, they've managed to convince the Linux kernel, I think, in a lot of distributions to ship with FQ coddle default.
Yep.
Do you have like a new recommendation on defaults, what they should use?
Well,
if
at the moment, I wouldn't recommend FQ coddle as a default for the dual Q couple, just because we haven't been, we haven't implemented it. So it's pointless having default that you haven't implemented. The Pi code, we get as good or better latency in the classic queue as FQ coddle anyway, without having all the queues. So I'd recommend that at the moment just because we've implemented it. And in fact, a later slide in this set says we have now released that code. Well, we had released it before, but we've really tarted it up and it's sort of bulletproof now.
That was another question I had. What's the state of the running code and getting that included in Linux mainline and so on?
Getting it included, the status is that we haven't started attempting to do that yet, right. But we have now released it.
But this is like a 2019 thing, you think, or?
Yeah, 2019 would be a good, yeah. Aiming for sort of next March, something like that, yeah.
Mia Kuleman, so I would like to add to that discussion that I think that is actually kind of an alternative to FQ coddle, because the goal of FQ coddle is to separate the small queues to give them low latency, while if you have L4S, you don't need it anymore. But I mean, this is a different deployment story, so, but. Yeah,
I mean.
Yeah, and I think the overall theme here is to enable all the deployment scenarios talking about. I don't think anybody is advocating that there is exactly one way to roll this out.
No. And ultimately, what you want to do is make sure whatever you roll out is no worse than what you've already got. And
Let's see if we can move along to the rack issue, which is also going to take
okay.
a pile of time.
Yeah. Okay. I guess I just will say one more thing, that if you've got end system congestion controls that are going to give you low latency, which is the whole point of L4S, then the real aim of all this is to be able to have low latency in your high bandwidth applications for the future, not just low latency for the sparse applications now. That's the extra thing you get aside from FQGODL. Right, next. So moving on to exactly what David wanted to hear. This is a copy of the slide from last time. We added a fifth requirement. There's requirements in this draft for what senders must do. And we added a fifth one saying that the sender must count in units of time when it's considering loss detection, not in units of packets, which is like rack. Sorry, counting in units of time is like rack, whereas in units of packets is like the 3G back rule. And that was to give link technologies that support L4S the ability to remove header line blocking delay. All right. Now, I realized in discussion with David, who's coming up to the mic, that I'm not going to explain all this again because I did this last time, but I realized that this point doesn't just apply to rack. I think what was behind David's question, from what I understand it now, is it's more general. So I think the more general question is, could L4S get stuck on DC-TCP? And David's concern was DC-TCP currently hasn't got rack in it. If we make it a requirement that you must have rack, then we're claiming that you can do early trials and tests with DC-TCP, which exists now. But then can you get stuck on that, particularly in the sort of environment that uses a lot of DC-TCP already, like a cloud data center or something like that, where you've got a lot of end systems that aren't under the operator's control. So they can't say, okay, now we've got a new end system congestion control, get rid of all your DC-TCP, because it won't go away. There's all these Windows machines, all these Linux machines that people stick in there of whatever release they want. And so David's concern was we could end up getting stuck in the trial state with this thing that doesn't comply with the requirements. And so how do we get out of that state? If we start doing trials with things that don't comply with the requirements, how do we move to a production environment? David, do you want to clarify if that is the real question?
Actually, that's a consequence of what I think the real question is. I can let you go. Your choice. Since you're up there in the victim position, your choice as to whether you'd like to go to the rest of the slide or whether we'd like to start the discussion here and let the audience read the slide on the screen.
Well, I'll carry on with the question because I think it's a valid question, even if it wasn't your question, or wasn't exactly your question. And so the possible answers to that are either you can just move gradually and you don't get all the advantages while you've got all these TCP things still using that queue, but they're going to move out gradually and then it all becomes sweetness and light and apple pie, just like the internet generally happens. Or you can do active things as a network operator, like adding policing / queue protection to get rid of things that some of the aspects of DC-TCP, like requirement number 4, which it doesn't actually scale to very low round trip times. When it does, it becomes unresponsive because of the 2 SMSS minimum window, and so it pushes up the queue delay and things like that. So you could deploy queue protection for that sort of thing. You could deploy policers, etc., etc. But the main point is that you start running out of general answers. You have to get into each specific requirement, and the first three requirements are all about essentially TCP friendliness with old TCP, and it's all to do, and RTT bias and things like that. And so I really don't think you need to worry about that. If that's a problem, it's been a problem forever. And the idea of putting in these requirements is to make it better from the start. But if it doesn't get better right from the start, it will get better fairly soon. I wouldn't really recommend putting in rate policers and things to enforce rate fairness and all the rest of it. But, you know, that's up to the network operator. Number 4, I've just mentioned, is more problematic because it's what I call latency fairness, if you like. If you've got a service that offers low latency and then you've got some congestion controls that don't comply with that requirement, then we've been developing a queue protection mechanism which kicks out flows that are the ones that cause the queue to go up, and probably be talking about that at the next IETF. So not got any material on it yet. Not fully finished testing it either. So that's one possibility. Another one is with the final point, which is what primed David in the first place. If we set the requirement to detect loss in units of time, what that means is if you've got congestion controls on the network that are not doing that, the reason for having that requirement in there was then it gives more flexibility for the network to be able to turn off resequencing, which is trying to keep things in order in the network just because TCP is so sensitive to ordering. And so we wanted to start from, if you like, a clean slate where we said, well, that's a good requirement to get rid of. A good behavior to get rid of is this 3 pack rule. And let's move to a time-based rule, which is what I'll explain this in TCPM and at the workshop that David mentioned on Saturday. But if you have congestion controls that don't do that on your network, what it will mean is that if you do start allowing more reordering in the network, those congestion controls will start doing more spurious retransmissions, right? And so in a sense, you've got a mechanism for kicking them off gradually by gradually opening up that space and allowing them to hurt themselves until they upgrade.
Okay, so this is David from the floor again, and I want to try to take this up a level because I believe let's see, the middle name of the IETF is engineering, and I believe we are looking at an engineering trade-off across levels in the stack. And I think Bob's actually done a nice job of summarizing this at the very bottom of the slide. I'll observe that this slide and all of the details on it are a consequence of making an engineering decision one way, and I'd like to focus on the engineering decision. In essence, the trade-off is roughly as follows, that if you don't impose the rack-like requirement to detect loss in units of time, we have existing code we can use. It's DC-TCP. It works with this now. It will continue to work at the cost of spending the engineering resources on the links to do the resequencing and the buffering required. The reverse engineering trade-off, which is the one that leads to the whole discussion on this slide, is to say that the cost of resequencing in the links is getting out of hand, and the benefits of removing link resequencing is worth all of the cost and complexity on this slide and beyond, including starting out with no running code that can use L4S as specified. I don't know what the right answer is, but I do think we need to have more discussion about that engineering trade-off, as opposed to coming in and asserting that it is mandatory that we in transport enable the link designers to turn off resequencing. I think we need to have an engineering discussion across those two communities of interest.
Yeah, okay. I nearly agree with that. Well, I don't think we need to not put this requirement in. What we're talking about is whether we're a bit lax about enforcing the requirement, and given the IETF doesn't enforce its requirements anyway, I think we should put the requirement in.
We haven't. Can I try sharing a little bit here? We haven't actually discussed whether that requirement should be in from the point of TSVWG, and we certainly haven't talked about that in INT and ops and other areas, because this is a change to this for data center TCP, which obviously is a transport thing, but it would affect anything that also goes into that queue. And your previous slide showed other transports putting things in that queue, such as video and other weirder stuff that I don't understand. It doesn't come from transport, but it's an app stuff. And these people will all be impacted by this decision.
Yeah, that's true. So, okay, so let's try and explain this impact.
Let's try to make sure people understand the decision facing us and consequences. I don't believe we can make. I don't believe, and this is speaking as a individual, I don't believe we can make it here and now. And I'd prefer that we have an understanding of decision and consequences.
Yeah. Can I try?
Go
and help that understanding? There is no requirement on the network to turn off resequencing for a start. What we're aiming to do here is put a requirement on end systems to be more liberal, if you like, about the way they deem that there's been a drop. In other words, RAC shows the example of how to do that. Then, and actually I didn't point out, the important two words on that bottom line in magenta there are to scale. So then as networks scale, they can scale by doing more link bonding, not worrying about getting things back in order before they leave the network. But there's like a transition point now where they've obviously got the speed that they've got at the moment. They can cope with that. And we've got a certain balance point between the way reordering is perceived in end systems and how much is allowed in the network. What we're saying here is, well, let's just move some of the complexity into the end systems at this point in history, if you like, as we're starting a new queue. And then as networks scale, then they can take up some of the liberalness that the end systems are giving them, so that they can make cheaper, faster networks.
An assertion that end system modification is easier than X has a remarkable history of being wrong for surprisingly large sizes of X.
Yeah. But I'm not making that assertion based on just a general end systems are always easier. I'm making it on the assertion that the way RAC works isn't complicated. It's
I don't care. Yeah. There are systems running out there that are better part of a decade old, and they get patched at risk of the operator's life or at least career. I said I think this is an engineering trade-off. I understand that you firmly believe that enabling links to scale without resequencing buffers is the overriding priority. I will echo Gory's remark that I don't think you've yet convinced TSVWG of that, and we need to have a discussion about gaining consensus of that, as opposed to assertions that it's true and the cod liver oil won't taste all that bad.
Okay, so I guess. I guess the main place where you think those discussions ought to be isn't so much in the link people's areas, it's in the RMCATs and TCPMs, because that's where the pain's going to be.
We need to.
Yeah.
And more, but yes. Yeah. Okay, so we need a way out of this. And you understand what the chairs are saying. I don't know how to engineer it. If you've got a suggestion of how to get that process going, that's okay. Otherwise, we can sit together and we can make one, because I'm not against this. I can see the rationale, but I just want to know that the IETF believes it until it pops up to the IESG, and then
Yeah,
it
okay.
comes
Yeah.
right down again to us.
Yeah.
That's a nice little gift back saying, oh,
Okay.
by the way, guys, we don't know what you're saying here.
Well, I have arranged to talk about this in TCPM. We've got 20 minutes on this in TCPM.
Yeah, that helps.
Which will help. I haven't arranged in RMCAT. I can't think of anywhere else.
That might.
Um,
Let's. Okay,
yeah,
we're
yeah.
going to work offline with you to try and do this. And other people in the room, if you are interested in this, please pipe up on the list and talk to Bob, talk to us. We need to get an answer on this one.
Okay.
And we
Okay.
need to move along fairly quickly, because I think we're
How
now
much longer have
eating
I
into
got?
the times for the optional presentations.
How much longer have I got?
Negative at this point.
Right. Okay. Because that was just the first draft.
Okay.
I'll run through this quickly because there's not serious issues here. It's just telling you what's happened really. The dual queue draft. Greg did a very useful review and pointed out that the normative requirements got in there. We tried to be minimalist, and they were a bit too minimalist because if you just follow the normative requirements, you wouldn't have anything. There wasn't enough in there, you know. Right. So they were really only normative requirements about the controversial things, not about the basic stuff. So we added the basic stuff like you must have 2 queues in a dual queue. You know, it's sort of.
Yes, please do.
And and you must apply ECN marking, and what was the third one? Yeah, and the relation between the square relation between the 2 queues. Greg reckoned I don't know whether this wording satisfies Greg now. I haven't asked him that, but it didn't seem to be enough the way we'd written it before to link back to one of the equations. You know, it just said the power must be 2 sort of thing, which I think this is a stronger statement of it's got to be lower than, no lower than, et cetera, et cetera. And the final one there, to say that the parameter, and this is actually one of the management requirements, for the target queuing delay in each queue must be expressed in units of time. Again, you know, so it's the same thing as Pi and CODL and everything does now. Pull that one out as well. That one Greg didn't suggest, but I noticed that one. Yep. Okay. And if anyone's wondering what the little stars and footnotes are, the must be 2 queues. I've added a thing to as a get out clause, so you can have more than 2. You know, and in the process of doing this, had to rework all the equations in order to be able to refer to that equation as a normative requirement, because realized that well, Greg pointed out that they weren't actually rigorously correct, and it was because we were equating instantaneous things with values that only applied on the average, and so reworked all that to make it more rigorous. Right. Right, I mentioned the management requirements adding details as the 3 most interesting words in the world. The main thing is for queue delay measurement, what we're suggesting is that an implementation should allow mean and 99th percentile queue delay to be derived. Now, 99th percentile is quite a difficult thing to do, particularly on cheap equipment or whatever. So we have suggested a coarse histogram method for doing that. And the idea of saying this is because we want, as experiments proceed, and also, you know, existing experiments with FQ-CODL, with everything else, so we've got something to compare. And I did notice that in all the AQM drafts, there are no management requirements.
And I did notice from Wes that we are going to need to get some more experience of how to manage these things before we take the next lot to the IESG, because that wasn't so pleasant for the AQM chairs.
Yeah, I must admit I was surprised that didn't get picked up by the IESG, but yeah.
And I think they will now.
Yeah, because I noticed when the RFC 8311, which enabled all these experiments that David did, one of the IESG comments was, you'll need to ensure that all the components of this have experimental management and operational requirements in them. And so I've made, well, actually, I'd already made sure, and then I went and checked the checklist in RFC 5706, and I'd already done it all. So
That's good.
Yeah.
Keep going.
Right.
That's a good thing to do.
So then the pseudocode, we're getting near the end. We had a step AQM in the L4SQ, just like DCTCP has a simple step to turn on, start ECN marking above a threshold. We've generalized that to a ramp because we believe that we want to enable experiments with faster convergence when we move to TCP, the thing we're calling TCP Prague, new things beyond DCTCP. And we think a ramp will allow more faster convergence. And the other thing is Tom Henderson picked up on, there was an assumption that we were using shared buffers, and because that's how we'd implemented it in Linux, partly because you've got a very small queue generally in the L queue, so you didn't really want to allocate a lot of memory to that just in case, given you had spare memory across the two. But he pointed out that with large C bursts, classic bursts from slow start, you can get tail drop, which then hits the other one if you're using a shared buffer. So the less memory efficient but more isolating way to do it is use dedicated buffers. Right, next.
Bob, I think we should take the status updates while I ask a few questions rather than talk through them.
Okay, yeah, I can just do that.
These are in the slide deck. Could I ask who has read the latest dual queue? I know it's pushing it. Has anybody read the latest dual queue draft?
You'd be pushing it because I posted it this morning.
Okay, there's a follow-on. Who plans to read the dual queue draft that Bob issued? 1, 2, 3, 4, 5, 6, 7, 8. At least 8 people in the room. That's good. That's good. And we need some reviewers for these documents. They are nearing ready. They will never be ready unless people commit to review them. We saw the benefit of Greg White going through with a fine-tooth comb. The other documents are now maturing as well. Does anybody wish to volunteer as a reviewer?
Not good.
We will resort to military-style recruiting.
If you're interested in the work, think about that. Contemplate, because we will need review from various people on each of these documents before we take them further.
So those that were going to read it, is there any chance you could review it?
That was obvious. And required if we're going to progress.
Okay. I have one set of volunteers to read all 3 and review them. So from outside the room. So. Right.
I think we're done here.
We're done there. Yep.
Magnus?
I did just want to say the code, I will post a link to where it is.
Excellent. Good use of the list.
Yep.
Okay. Magnus has slides, right?
Magnus has slides, yes. This is useful to do because it comes up in quick soon, so we should be looking at this one.
Right. We have about 25 minutes of time left and nominally 35 minutes of material, so brevity is a virtue.
Okay. So Magnus Westlund, Ericsson. Yes. So I just represent the people working on the ECM part of Quick. So, but I'll give you an update here. So did I do the wrong way? Yes. So yeah. So anyway, this slide is just a recap, and it shows also one of the changes to the ECN format. But this is the ACK format with ECN. Now it's an ECN section, which is it's not anymore different named frame types. It's using the lowest frame type bits to separate between without or with the ECN section, and the still the counters.
So Magnus, is this targeting the first release of Quick?
Yes, it is. And we see in some implementations already in it's at least parts of it. So it's good. What's really happened has been that, ACK ECN was replaced by just ECN section in the ACK frame and moved to the end of frame. So it's a little bit changed on the format, but it's the same information, just structure slightly different. we also clarify that because of quicking have a different packet sequence number depending on the protection levels, each such packet sequence number space has its own set of counters, which is important so you can actually test on the initial handshakes, etc. Quick also coalesce, which means putting multiple quick packets, potentially at different protection levels, in the same IP-UDP packet. And clarify that, yes, you need to count each of these different quick packets will up their counters in their representative sequence number space. So, and there is some restructuring in the text. So, please, I think it's a fairly good shape, but you please go review this if you're interested in DCN. But also spent a lot of time, including quite some time at the interim meeting for Quick in New York in September, was this about more explicit information around the ECN bits. So should you actually get the ECN markings for each individual packet? The conclusion was for V1 to not change this. There's one aspect of this is actually you get quite a lot of overhead when you need to, for each CE mark, indicate the changes, etc. And as the BDP goes up, and especially in the context of L4S, where you will have frequent changes. So this is going to be a challenge going forward if you could do L4S combined with ECN and explicit marking. That's also some discussion about which transitions, etc., was relevant. So this is possible that will happen in the future Quick version. So it's something to think about. Mirja?
Yeah, Kulevin, I should probably know the answer to that question, but you will tell me. Are the counters in packets or in bytes now?
Packets.
Okay, because in accurate ECN, we actually have byte packets, and that would also address the problem with coalesce packets, right?
Yes, this is so, but at the same time, I don't think it's going to be that significant difference for you. So, as a sender, you're going to have a running average, so to say.
Yeah, so I mean, this is the trade-off we make for accuracy, basically. Instead of reporting on every packet separately and having a packet, we were at least reporting on the bytes, which gives you slightly more accuracy for future congestion control schemes. And especially if you have different size package, which can easily be the case for Quick, it might make sense.
Yes, but at the same time, it's up. I mean, going to bytes, you have to think about how you report, and it's up quite a lot of the counter space, etc. So there's a trade-offs here, and I think and this is actually why we want to go forward discussion for V2 maybe to do other ways of reporting this, etc. But for V1, I think it's the simplest, etc. And it gives you reasonable, especially for the congestion controllers that. I
mean, like we had all these discussions about accurate ECN here as well, and we didn't really convert, or like we did converge now, but it took a long time. But I think like one thought I didn't bring up earlier in Quick was I think it would actually be nice, given we are so close, to actually do the same thing in Quick than in accurate ECN, which would be byte counters. Because then a congestion control scheme can easily, be implemented in one of the two protocols.
So my question to that would be, is that something that is critical to get in Quick V1 and asked for on the penalty that it might mean that no code is incorporated in Quick V1? Or is that something that could be incorporated as the refinement in Quick V2?
So I think it's it could be later, but it might not happen later, right? And it's a small change. And I'm sure Bob wants to say something as well.
That's why I'm at the mic. Hi, Bob Briscoe. One of the reasons we put byte counters in accurate ECN was to allow for the fact that over the years TCP has evolved to protect itself against all the attacks that are used by splitting acts and things, or could be used. I don't know how much these attacks are real attacks, but we wanted to make sure that we learned from that experience. And I'm not saying that those attacks are possible in Quick because I haven't even thought about it, but just as a high level thought, when you do your feedback in packets, that allows act splitting and all the other attacks that David Weatherall and so on came up with.
But that's not possible in Quick because the sequence number is if you're retransmitting any data frame, you're still in new packets. You all would still account to it correctly. So,
yeah. And then there's other things like, for instance, something I'm going to be talking about in TCPM later this afternoon is the ability to be able to alter your response depending on the size. Like if you've got an ACK with an ECN on it, you don't do a full congestion window reduction compared to a full data packet and things like that. So it's those sort of things. It's used with FICAP.
I think that's useful input, but we need to make a trade-off in Quick as to what we can get in the first version and then what we can get expertise in later.
Yeah.
Carry on, Magnus, and let's
yes.
get to the
so really this, and I have two basic question slides more, but related to parts what we discussed already. But this is I think from my perspective is that these are not really open issues. There are solutions in Quick V1 which do make them work, and basically avoids those issues, but they might arise in the future because people want to do other things which changes this. So one was Quick has this delayed acknowledgement mechanism. So at default 25 milliseconds you can wait before you send an ACK, and its spec is going to say ACK every 2 packets, Reno style. But ECNC says immediate acknowledgement, which gives you rapid response to congestion events, which is fine for classical ECN, but for L4S or any kind of that, it's less good, especially if you're like, okay, you could probably wait a quarter of an RTT or an eighth of an RTT before you send an ACK to reduce the ACK frequency, especially as the ACK processing is probably one thing which burns quite a lot of CPU, etc., for the protocol, and it's probably so. And then it's been shown that you can get it to work, but at least with other congestion controllers like BBR, etc. So that has pacing in the sending. So this topic is coming back as Quick goes into V2 and evolves, etc. People are going to do want, and there have been discussion about basically having sender side controlled what the receiver does for hacking, etc. So that's probably going to be discussed later in Quick, etc. And then we come into this question about ECN also and L4S and how we handle this. So that's one thing. And the other one is actually, okay.
Sorry, and I should know all this. So what we say in accurate ECN is actually that when it changes, like if you receive a non-CE mark packet and then you receive a CE mark packet, you should send an immediate ACK. But if you receive like a whole bunch of CE mark packet in a row, you don't have to send an immediate ACK for everything, only if the marking changes again.
Okay.
I think that's the right thing to do here as well.
Probably. I'm a little bit worried maybe in those cases where you might see fastly flipping CE marks. But yeah. So, and also this utility of this more detailed C information about what's happening on the different packets, etc. Yes, byte counting, one possibility to do it that way rather than having encounters, but also it's the question of how you advance the congestion controllers, etc., what you need. So it's time to think about it, and it's going to affect this and how possible to do it. So yeah, that was everything from me. Any more questions?
Thanks. Please continue to think about how Quick should use ECN. That's a good topic for doing in this working group, and we can pass it on and coordinate with the Quick people as they continue to evolve this.
Okay, we have a
quick working group chair who can say better than me.
Yeah, Lars, I just want to say that this cannot happen at the usual speed of TSVWG, right? So if you want to do something here, you need to do it now, or you need to shut up, seriously, because we're shipping this thing.
Is this V1 or the whole of Quick? So yeah, that's what I was trying to get to. V1's going. Lars says so. Decide now if you need to speak on it.
Yeah. So, okay.
How much time have we got?
We've got about 15 minutes. What I propose to do the agenda is give Greg 10 minutes on this draft. Bob, skip L4S diff serve since we got the major issue on that one resolved, and give Iju the last 5 minutes so that we can check we can check that draft off.
Right. Thanks, folks. So I submitted this draft shortly before the deadline, I think minutes before the deadline. And it was intended as kind of a problem statement. Bob gave some hints as to what the subject of this is, but essentially, are there ways you can identify flows, traffic flows that can share the LQ in an L4S system with the L4S TCP? So, next slide. Okay. So a couple inspirations. The first one, all right. Coming from the FQCODL context, so FQCODL has this functionality where it identifies automatically sparse flows and gives them strict priority over the bulk TCP, bulk traffic flows. It does it in an application neutral way. It's not looking at protocol construct. It's just looking at the packet arrival behavior. Is there a way that we can get a similar benefit in non-FQ systems in devices that maybe can't support or don't want to support the FQ construct? And then the second perspective is, again, from the L4S context, where you've got these two queues. You've got one that provides great latency performance for this new version of TCP or the DC TCP and future versions. What other kinds of traffic can you include in that queue as well? Next slide. So some high-level goals really are provide reliable, and in this case we're talking about kind of statistically fairly reliable. P99 is our 99th percentile is kind of the metric we've been using. Low latency and low loss, both for these sparse traffic flows, are giving the same kinds of performance characteristics that the L4S DC TCP traffic can get through that LQ. Also allow capacity-seeking applications to compete for bandwidth. So again, as kind of a differentiator between the L4S approach and the FQCODL approach, where congestion controllers are sharing a queue and then allows for innovations around the way they seek capacity and share bandwidth. And then supporting L4S as part of this as well. Okay. So we came up with this terminology of just using terms queue building and non-queue building to refer to application flows that can fit well in the two queues in the L4S system. So queue building flows are definitely the capacity-seeking flows that are using a traditional congestion controller, whether that's Reno or Cubic or even BBR. As well as highly bursty flows that maybe aren't using a congestion controller but are sending large messages, lots of back-to-back packets that would exceed the link capacity and cause a queue to build up in the network. And then non-queue building flows are all the flows that don't do that, right? That they're typically relatively low data rate, not capacity seeking. They may be latency sensitive. In fact, a lot of them maybe are, but that's not necessarily a criteria here. And the idea is that they're highly unlikely to be sending large bursts of traffic that's going to build up a queue in the network, but they might send short bursts. Okay. So along the lines with the L4S approach, we've got these two queues. Effectively, that works well for queue building flows. You've got the classic queue. It's got a deep buffer, generally using some kind of a classical AQM, Pi or CODL, and then a shallow queue for these non-queue building flows. Next slide. So then the question is, how do you identify them? How do you know what's a non-queue building flow versus queue building? So the draft talks about a couple of ways to go about doing that. One is allowing the application or the operating system to mark packets. And the view there is that an application or the operating system has a pretty good, I guess, concept of what the application behavior is, and so could mark the traffic accordingly. And then introduce this possibility of defining a standardized code point to indicate that, to indicate this non-queue building behavior. The other approach that the draft talks about is by having the link monitor the arrival pattern of packets, similar to the way that FQCODL does, at least conceptually similar to that, and build up some kind of a metric in terms of how queue building a certain flow of packets is. And then the draft talks a little bit about kind of bring those two together, kind of a trust but verify approach, where you have this marking mechanism that an application endpoint can use to say this is a non-queue building flow, and then you validate that in the network element. So, first of all, how trustable is that endpoint marking? And I guess the view here is that there really isn't an incentive to lie. That the queue building flows that are going to be sending a burst of traffic, they'll do better in the C queue or the queue building queue. The ones that are non-queue building will do better in the non-queue building queue. So there's not really a reason to mismark traffic, but sometimes bad things happen. Things get mismarked. Also, it may not be totally concrete how an application can characterize itself if it's kind of in the gray area between queue building and non-queue building. So introduce this queue protection function, basically looking at the traffic arrival patterns for packets that are marked non-queue building and redirect them to the queue building queue if they start to cause queuing delay.
I think you have to do that. Bob mentioned RFC 5706. One of the things that you will find in there is that which can be configured can be misconfigured.
Right. Okay. Next slide.
I'm sorry. I think you need the protection. I don't believe the incentive system is going to result in an ability to rely on the marks. The incentives are indirect, and they rely on people configuring applications correctly. That which can be configured can be misconfigured.
Yeah.
Sorry, that which can be configured will be misconfigured.
I'm Dory First, as being the RSVP Stucky for the moment. Some people just don't know. They have a flow, they don't know what it is.
Sure. Yeah, so definitely maybe some value in this trust but verify. It may be mandatory. Yes. So got some feedback on the mailing list already on this. One was, okay, it wasn't super clear in the draft what the problem statement requirements were. So I'll update that. And then sorry for the little snarky comment there.
I will observe that the idea of running the inbound half of FQ coddle to understand flow behavior seemed to have emerged from that fight. So it wasn't all for naught.
Okay. That's it. So I'll take, I guess, time for questions or no questions or.
Does anybody have any questions?
Yeah. Okay.
Thank you for writing the draft.
All right.
We have one question.
Hi, Martin Duke, F5. Interesting idea. Why is it that, so as a queue building, so if I understand correctly, a typical like TCP file download would be a queue building flow?
If it's using a traditional congestion controller, right?
Right.
Yeah.
Yeah, I wouldn't take it as a given that the incentives lie with me staying in the queue bit. I mean, we know buffer bloat is a big problem. At first glance, I would think that the small queue would be advantageous to me. So I mean, just to hammer a little bit more on the point of incentives and that you have to verify, I'm not sure that's accurate. I mean, in a way, just having small queues in the network would be a good thing, as just a broad architectural point. So to have to legislate the system where we have a shallow queue and a deep queue, well, why not just all have shallow queues, I guess.
Yeah. If you like lots of drops when you send your burst, then you can use a shallow queue. But so there's going to be different behaviors. We shouldn't rat hole on this. We should talk about this on the list, because this is a great topic to go through on the list.
Okay, thanks.
Last segment, issue. And this is the topic that we moved here from Wednesday.
Yeah.
And there's the. I'll be able to. Okay.
Yeah. Hello, this is Yizhou speaking. So I'm going to talk a little bit about this new work for this overlaid path segment forwarding thing. Next page, please. Yeah, so here is the motivation for this. So quite a lot of researchers and even some deployments already trying to leverage the cloud router nodes in various clouds to build a better path in order to provide the performance more closer to the list line. So we also ran some preliminary experiments that shows 71% of chances that we can find a better overlay path compared with the default one. So now it's becoming more and more practical thanks to the technologies of the NMV in the various instances that's provided by the cloud providers. Next page, please. So we want to take the opportunities of this overlay path over WAN to do loops, which is the localized optimization on path segment to achieve better reliability and throughput. So basically, the picture shows under the end-to-end path, naturally, the path had already been broken into multiple overlaid path segments. So there are segments running between two overlay nodes. So there are some problems and opportunities that we're trying to overcome, like slow loss recovery over the long haul, and the sending rate decrease, and the sender might be, the inaccuracy in the sending rate, decrease. And also with this overlaid path, normally the virtual nodes have limited capacity, and in case of the impairment of the virtual hub, we need to handle the detour or reroute. Next page. So we figure out some of the key elements of a solution. There basically includes the local recovery, which means the recover between two overlay nodes. And the second one is the congestion control interaction. We certainly want to avoid the retransmission competing between the end-to-end layer and the local recovery. So there are some ideas regarding this. And the third one is the traffic splitting and then recombining to solve the capacity issues. And also, if we want to do the FEC, the FAC, over multiple path segments. Next page, please. So we are trying to have this side meeting to steer the work. The loops discussion will be tomorrow evening, 6:30 p.m. in 7th floor, meeting 5. So the purpose is to discuss the use case and the problems and possibly some potential solution ideas and what should and could be done in IETF. Here are 2 related drafts. So everyone is welcome. And if you are interested, please talk to me or Carsten, who is the organizer. He's not here. Yeah, so thanks.
So thank you for the talk. I'm sure many people recognize things on that list of things that were desirable, and we will have opinions from the transport area on these topics. So please go to the side meeting. Please talk to the presenters. Please use this list to talk about this draft. And I think we're over for today, are we, David?
We are.
Thank you ever so much for attending. Please come to the next session.
Okay, where are the blue sheets?